Welcome to this next iteration of the Sustainable Futures Seminar Series. For those of you who don't know me, I'm Mike Shaver. I'm Director of Sustainable Futures, as well as polymer scientist that works a lot at the interface between plastics and recycling and sustainability. The Sustainable Futures Seminar Series was created as one of the offshoots of the Sustainable Futures Research Platform. This is a new research platform and is one of the several research platforms, including Creative Manchester and Digital Futures, that looks to capture our work in interdisciplinary research areas. And so sustainability, and in particular, environmental sustainability, is one of those key areas. And for those of you who don't know what a platform is, well, really this is a way to bring researchers together with lots of different perspectives on these challenges. And from that, you really create more resilient, more robust solutions that can be enacted really, really quickly. And so the goal is to help to align these different research areas, to connect them up when perhaps different groups are thinking about the same challenge in different ways, to help to grow those, and so support in building those research communities and writing grant applications. And I think most importantly in terms of today is to celebrate the things that we're already really doing well. So hopefully this seminar series will introduce you to new researchers who are doing really cool things across the university, as well as provide an opportunity to kind of connect and learn about some of the great things that are already going on. So we have two talks for you today. Oh, I should also say, so in the chat function, you'll see a link to our Sustainable Futures website, as well as the sign up for the newsletter. This is both an important email for you because it has lots of neat stories about funding links or new opportunities or best practices going on, but it also helps us understand the people who are interested, because when we're planning the stuff that we are doing, we really need to know what it is that you want to do as well. So please do sign up for those activities. So as I said, we've got two talks today. The first is by Ian Mell. And so Ian is a reader in environmental and landscape planning, and has connections through a lot of different institutes, but in particular the Manchester Urban Institute. And I'm going to turn the floor over to him for his talk. We're hoping that he can unmute himself. All right. So Ian, feel free to share your slides.
Okay, thank you very much, and thank you everybody for coming. It's a pleasure to be here, and hopefully you'll find what I have to say quite interesting. The first thing to say is this really is ongoing work, and the way in which we think about funding the environment and funding our public green and open spaces is a topic which has been really prominent for at least 10 years, but to be honest, for over 150 years, and is at the very centre of what we might call town and country or urban planning. We were asked to do no jargon, and I immediately see that I've got one very jargony word, green infrastructure. I'm not going to define it, but I will put a definition in the chat because it basically means everything and nothing at the same time. But what I'm going to talk about today is, as I say, ongoing work around how we look to finance public environmental management in the form of parks, street trees, other forms of urban green and open space. And it comes at a time where, as usual in the UK, in a state of flux. We've got government which has flopped from left to right and currently in a very centre-right position. And within that, the environment is something which is notionally important, but actually sometimes gets pushed way down the agenda when we're talking about infrastructure provision or housing or other forms of social care. But what we can see in the UK is almost a 15-year discussion about how we can improve the quality of urban landscapes, how we can improve the quality of urban areas, and particularly how we can improve the long-term sustainability and resilience of environments across the UK. And within UK planning policy, we see the promotion of the environment and sustainability and resilience thinking in the mid-2000s. And then in 2010, we get a new government, and a lot of this detail, a lot of this focus gets stripped out in favour of a more streamlined form of public planning. So over the last 11 years, we've had a form of planning in the UK, which is very much about how many units can we put in the ground, how quickly, and what's the return on investment. Might be quite a cynical view, but I think it's one that plays out when we look at more recent planning reforms. However, within all this, within this fluctuation of how much we need to develop and where, there are a few beacons of light, really, and it always feels slightly strange to praise the current government, who have not always been the most forthcoming in terms of environmental consciousness. But the 2018 25-year environment plan really set out an agenda which was to think about future-proofing the UK environment around climate change, around health and well-being, and particularly thinking about aspects of environmental economics as well. And part of this is promotion of things like biodiversity net gain. So any development should improve the quality of nature and biodiversity, the use of different forms of accountancy, so natural capital, so to really understand how and why we might value the landscape, and thinking more about developing new standards or new approaches, such as local nature recovery strategies, to really place nature at the forefront of planning in the UK. This has been successful to an extent, but one thing that we can sort of argue is that the current thinking of government is about speed, is about digitization, and is almost about a lack of focus on the big issue. So the Planning for the Future white paper talks quite explicitly about the fact that we should have beautiful places, but it doesn't actually tell you what a beautiful place is or how we actually define or create beautiful places. And so within this context of a fluctuating policy environment, there's been an ongoing discussion as well about where the money comes from to ensure that we manage the environment in a positive manner. And one thing that we can see quite clearly over the last decade is a decrease in the amount of core grants given by government to local authorities. So local councils have less money to deliver services. We've had a large-scale rethink of what services are legally required versus what services might be additional. So we think there maybe about social care, for example. And we've seen a major shift in terms of the capacity of the environment sector, and particularly in local government, to deliver sustainable landscape management. And so one thing that this has really led to is one might call it a gutting of local service provision in terms of the expertise and the knowledge of people who actually understand how best to manage the environment. And we've moved to, in many ways, more monocultural forms of management of how many times do we mow the grass each year, and let's not put any bedding plants down anymore. Now, this has led to quite a dramatic kickback from the environment sector, and particularly from the park sector, because they view this as a very personal attack on their profession. But what we are starting to see is a kind of a rethink, really, a sort of a rejuvenation of the opportunities and the skills and the management ideas that can come through from all these people who have been working in parks over a period of time. So one thing that sort of frames a lot of the work that I've been doing recently is this notion of whether austerity in the UK is solely about decline, divergence, and the creation of a vacuum of skills, or whether it's actually an opportunity for innovation. And I think this is a really important and key point, because in many ways the removal of funding has created a vacuum of skills, or a vacuum of organisations who are willing to come forward to fund and support landscape enhancement and landscape investment, therefore leading to decline in the quality of some places. But it's also been an opportunity for other, maybe non-traditional stakeholders to become involved as well. And this is really where sort of the focus of my research sits. It's how do we move away from these traditional understandings of who should pay for landscape enhancement, who should pay for parks, who should pay for football pitches, and are there mechanisms whereby we can work with, in collaboration with, or co-design with alternative stakeholders from the public or the private or even the community sector to really sort of find new alternatives to an ongoing problem. So whilst we have to acknowledge that there has been a decline in the capacity and in some places the quality of environmental management around green infrastructure and particularly parks and open space, there has also been opportunities for local government in particular to think sort of quite creatively about how they move this forward. And so what I'm going to talk through next is a series of ideas that have come through funded research from the European Union, from the Horizon 2020 Urban Green Up project, from a former Interreg 5B project called Value, so Value in Attractive Landscapes in the Urban Economy, and through a Value in Nature funded project, which looks at who could pay for green infrastructure in London specifically. So what we're seeing is almost a move back to the very simple basic questions of who, what, when, where, why, and how. And this is something that I always tell my students, go back to the basic questions. So who should be involved? What kind of green infrastructure can we invest in? Where should we put it? Why is it important? And how do we go about doing it? And one thing that's become quite apparent over the particularly the last 5 years, is that the nature of the types of green space or green infrastructure that we can invest in is diversifying, and local authorities in particular are looking beyond the simple let's just build a new park or let's plant some trees, and they're thinking more creatively about how they engage with sustainable drainage, for example, or even green walls and green roofs. And what we see in this is a far better and more multifaceted approach to investment that actually draws on the expertise of local government in terms of the legal regulations about investment in the environment, but also brings in SMEs, so small and medium-sized enterprises who might be innovators in sustainable drainage or green walls. It brings in the environment sector, so in the Northwest, people like the Mersey Forest or City of Trees Manchester, or even people like Groundwork. And it provides opportunities to think creatively at the site scale. So how do we address a specific problem, but also how do we sort of increase the size of some of these ideas to think strategically about how we invest in green infrastructure at a neighbourhood or even a city scale. And what this has really done, and what's been sort of brought out in research in London, is that depending on what kind of organisation you work for, there are barriers to your engagement with some of these ideas, which might be around operational or financial costs. It might be around a lack of knowledge or expertise, and it might be around the fact that you don't really see the return on investment value of such things. But what is interesting when you speak to particularly developers and business improvement districts in London is that they're starting to equate an economic value with a social and a cultural value as well. So particularly developers in London are looking at how they can invest in greener, more sustainable property and therefore sell it for more money in the market, and therefore have a better position in terms of their sustainability targets. With business improvement districts, they're seeing a lot of their members who are subscribers, who pay a fee to be part of the bid itself, thinking about the returns on investment from street greening. And this is particularly the case in locations around London Bridge and around Borough Market, for example. So I think what this really shows, and what this sort of potentially highlights in a positive manner, is the ways in which these alternative funders who might have been excluded because local authorities should be paying for green infrastructure are starting to take a far more prominent role in the allocation of funding, but also in the siting and the management of green infrastructure as well. Some may say it's quite cynical in terms of they're just looking at their long-term investments and improving the quality of their housing or their business portfolios, but others might argue that actually they're giving something back to their communities as well. I think if we take this a little bit further, we can see that across a whole number of different scales that there are ways in which the funding of green infrastructure and the funding of green and open space more generally can start to be rationalized from a very economic perspective. And so as I mentioned, the value in attractive landscapes in the urban economy, so the Value project, worked with a whole host of different techniques drawn from economics to try and look at cost benefit analysis, contingent valuation, look at hedonic pricing. And what this project really found that was across cities in the Netherlands, Belgium, Germany, and England, that actually people were willing to pay for improvements in their local environmental quality. And that was people who were residents, but also businesses. And so in terms of developing an evidence base which could be put forward to local government, there is quite strong evidence which is actually supportive of investing in nature. Yes, some people will always say, we don't like nature, we don't want that near us. But many people are sort of saying, well, actually having a greener and cooler environment is something that they strive towards. And if we move to particular examples from Liverpool and London, we can see that there are a whole host of different mechanisms to support this. Some come through the planning system, so planning obligations such as Section 106 agreements or community infrastructure levies. Some might come through the sale of land, some might come through local taxation, so council tax or business rates. But also there are opportunities to think more broadly about how we might engage the private sector in sponsorship deals. And the work in Liverpool, we always talked about, could we get Liverpool and Everton football clubs to pay for all the football pitches? Unfortunately, it never really went anywhere. But also you can think more creatively about parks trust or endowment models, and maybe the sale of small pieces of green infrastructure to fund the management of others in perpetuity. And what I think is interesting about the breadth of financial options is that they talk quite clearly to a diverse range of funders. So if you think about house builders and developers, they might be more attuned to these commuted sums or infrastructure levies that are linked to planning obligations. If we think about transport providers, it might be more about large-scale improvements of their building assets. So how can they have green walls and green roofs? And so what I think is quite nice here is that these contemporary alternatives, which can be seen in the bottom right of the right-hand image there, are taking a far more prominent role in some of these conversations. And yes, we now have quite a strong and robust evidence base to say this is how we should be investing in our urban environments. We have a whole set of mechanisms which can be used to provide that funding and to provide the benefits and highlight how the legal barriers or social cultural barriers might be addressed. And we have a whole set of people who might be invested in delivering these ideas. But one thing that we really need to be careful of, and I think this is where an interdisciplinary approach really works, is the fact that the way in which we generate income, the way in which we look at capital and revenue, income generation and spend from across the public and private sector is always going to be viewed differently depending on whether you are a public body, a private organisation, or whether you're a member of the community, so just a local resident, for example. So shifts towards the sale of land and therefore using that money for a parks trust or parks endowment and not always seem to be popular by local people because they see land being sold. And even though the economic rationale behind that might be quite strong, there tends to be a reluctance to sell land because people tend to get quite upset about it. In addition, we can talk about how the planning system itself might be used to generate capital and revenue funding. But again, there are always pushbacks here from developers who don't want to see their companies being told to pay more money to develop. Also, there's an ongoing issue there around the way in which we might need revenue spend, so money to maintain parks or green spaces versus money to develop new ones, because there's an ongoing issue around the delivery of new spaces, but having no money there to maintain it, and therefore it becomes a liability. And there's also a growing sort of body of work which looks at the way in which corporate social responsibility, i.e. ourselves here at the University of Manchester, could take a bigger role in providing funding for greening projects, football clubs or other developers, or even looking at more informal management with local communities. And what's come through in this work is that there's always quite a diverse and complicated mix of all these things happening in every location. And therefore, a whole process of negotiation, compromise, and discussion is needed to really bottom out which is most appropriate for Manchester, for Greater Manchester, even for the northwest of England, just to give a few examples. But linked to this is a corresponding conversation about the types of space or the types of green infrastructure we might use this funding to support. And some of that is around these bigger places, these public parks. Some is about street trees. Others are around smaller places which might take less money to maintain. And again, each of these different types of green infrastructure have positives and benefits, have different sort of amenities, so be it around climate change adaptation, be it around social spaces and recreational health and well-being, but also each have a perceived susceptibility really to ongoing funding. So is the funding for public parks sustainable or secure? At the moment in the UK, we might argue that it's not. Is private spaces and funding for that secure? We could argue that it is, because corporations have a duty and a willingness to invest in their own sites. And so when we think about investing in new facilities or new green amenities, we have to think quite carefully about the ways in which we then allocate funding for that, because as I mentioned previously, the ways in which we allocate revenue funding is often something which is far more difficult to articulate within a funding bid or within a management agreement, because there are far more intangibles once you put something in the ground in terms of what it will develop into. And so what we're really seeing is a whole host of future directions where they could be in the form of legislation, in forms of partnership, or new approaches to finance. And some of these are being brought forward by the development sector. So Grosvenor, who are a high-end house builder in London and across the country, are incredibly forward-thinking in terms of locating biodiversity, locating nature, locating green infrastructure within the DNA of all their new developments. So what they've done is almost got in there first. They've shown that there is a willingness within the construction industry to really present a more sustainable and forward-thinking view. In addition, sort of the DEFRA, so the Department for Environment, Food and Rural Affairs, so the government Department for Environment, investing in a new green infrastructure standard for the UK. So they're looking to try and find benchmarks to say all development needs to conform to a certain set of approaches that are based around access, around health and well-being, around particular targets. So what this suggests is that there is a movement in government that is supported by the passing of the Environment Bill to create more policy and legislation to support natural environments in the UK. One thing that's not come through here, though, as yet, though, is a reinstatement of public funding at the same level as we had in 2010. So there's almost quite a bit of a conflict here between legislation that is supportive of the environment versus funding which is far too meagre to help do that. But in addition, what we're also seeing is the shift in mentality and a shift in the conversations around who is funding this work. So moving towards the private sector, thinking about banks, big law firms, big manufacturing firms, and the way in which they might have to engage with urban greening factors or biodiversity net gain, for example. And that might include greater public-private partnerships to both align the skills and the knowledge that the public sector has with the finance of the private sector. Or we might end up with things like Parks Trust and Endowments, such as what they're doing in Newcastle at the moment, where they're using the proceeds from a sale of certain infrastructure to manage in perpetuity the funding for parks across the city. And this is quite a controversial idea. It does involve some land sales, but can be quite a good long-term strategy because that money is held outside of the public purse, so therefore it can't be used or diverted to other things. Or we might look at communities as well, so community asset transfers. So me or you could take over the running of a local green space if we had the skills, or starting to designate more local green spaces as well, such as being proposed by Fielton Trust. So these are all very much around people and around partnership, but there are also a growing set of discussions around selling green infrastructure and selling land because it might not be profitable, which is always very controversial. There's an ongoing debate around the commercialization of events and rents. So how do we actually make the most back from green and open spaces? And a greater reflection on how the development sector in particular has to engage, or should be engaging, with new standards and new benchmarks, including building with nature, which is a very sort of thematic-led approach to building standards. So how do you make your development more sustainable? By thinking about water, biodiversity and health. The urban greening factor, which looks at the quantum of green space in an area and asks for a figure between 0 and 1, and above 0.4 means that you have a high quality and lots of green space, and that's particularly relevant in high density urban areas and around green walls and green roofs. And of course, biodiversity net gain, so that all new development has to deliver more and better quality biodiversity, both on site or in some cases externally, but only of a very high quality. So in terms of this whirlwind journey through green infrastructure financing, I think the main take-home messages are the fact that there's a growing understanding that a multifaceted approach to funding is needed, both for capital and revenue. I think there's both a weakness and a strength in national policy in the UK that is supportive of some of this work, but the lack of public funding is still quite a significant drawback. And I think there's going to be an ongoing conversation about the way in which we either use land sales, commercialization, or benchmarks and targets to really structure how we might improve the quality of the landscape in the future. So just to say again that some of this work was funded by a Horizon 2020 research and innovation programme called Urban Green Up, and some by the Value in Nature's Placement Fund. My contact details are there. Thank you all for listening, and I'm happy to take any questions.
Thanks so much, Ian. That was really interesting. So if you do have questions, you can type them into the chat or put your hand up and you can ask it live if you wish. I might just kick things off. So it feels like there's a great increase in the diversity of actors, right, who are involved in this decision-making process. And certainly in my work in plastics, when some of those actors are looking for the appearance of sustainability instead of actual sustainability. So is there a risk associated with the quality of decision-making in terms of like what is getting installed, and how do you feel that this big change in funding is interacting with decisions about what should be put into a certain location?
I think the issue about greenwashing is very, very prominent, that there are organisations who would look at how do we just meet our sustainability targets, have a tick box and tick it off, and therefore they've delivered on that mandate. I think what we're seeing, particularly in London actually, is a far greater engagement with some of the more long-term benefits. So people are thinking about how do we ensure that our employees, our communities, the place where we're located actually benefits, rather than just being quite cynical and corporate about it. So I think there is a shift in mentality for some, not all, and some developers, one might argue, are still very much about numbers of units on ground and how much they can make. I think it does feed into questions about what type of investment is being made, because a public park is always going to attract more attention and potentially more revenue and commercial opportunities. And that's where this variety of the environment sector, landscape architects, academics, local government are coming together more frequently to work out what's best. So in Manchester, we've got the new Victoria area around Collyhurst, we've got Mayfield, all trying to bring these different stakeholders together to provide something which is for the city, but also for those private investors. So it can be a bit hit and miss, but invariably we're seeing people more attuned to this because it becomes more of a political and visual issue for more people. So they can't simply ignore it as they might have done even maybe 10 years ago.
And I think you had mentioned that there was this London developer who was sort of at the leading edge, and they were predominantly luxury.
Yeah.
Do you think that that's going to have, it's perhaps a concern in terms of the sociological demographics there, where you'll see investment at those high ends because that's a marketable tool people want. You know, there's a tie-in in terms of environmental sustainability, activism, and affluence. Is there a concern that that doesn't track through to the places which really will have the most societal benefit from green spaces in those lower income properties and lower income developments?
I think it's definitely a potential issue, and we see examples of green gentrification around the world. What I think is happening in London is that there's almost a comparable conversation happening with a number of social housing bodies as well. So Peabody Trust comes to mind as people who have had a very similar conversation internally about creating places that people want to and can live sustainably. And so at both ends, it seems to be that people are moving towards this. I would worry about volume house builders who may not be as engaged in livability ideas or sense of place. I think local government, where they can, and they are hamstrung a lot by the planning system, are trying to engage with this with developers at all scales. And I think they are having some success, but maybe not all the successes. But I think it's definitely something that we need to consider, because creating further inequality for green space and access and quality, I think, is something that we need to move as far away from as possible. Otherwise, we just repeat the mistakes that we've made historically.
Yeah, that's really interesting. I think you scared everybody off with all of the finance facts, so we don't have any other questions. I guess I would ask one other question in terms of, like, if you're looking forward, like, should communities be really doing this? It feels like passing the buck in a way, in that the obligation could be on government, but government is now getting communities to go and do that. And I can see the benefits for sure, but is there a concern that this is deflecting away from the obligations of government?
I have that same concern. I think communities are part of a conversation, but the onus should not be put on communities to take the lead in these things. I think that is a dereliction of responsibility in many ways. And I think a lot of developers would quite like to just hand over possession to local communities who might not understand the legal or the financial implications. Community asset transfers are quite complicated to achieve, and therefore you have to go through all these processes. And I think they can be really effective, but you have to think long term about the composition of the group. And I think where you've got buy-in from a local government or an environmental organisation, say City of Trees, I think there's more likelihood of success, because there is that capacity and that knowledge and that expertise to go with it, and maybe even someone who can step in if it doesn't work. But I definitely don't think we should be handing everything over to communities and say it's all yours. I think at some point they get bored, or they move, or their kids grow old if they don't go there. And I think it's, passing the book is not the way forward.
So there is now a question in chat, which I think is actually related to something which we think about often, which is like that how that green infrastructure in terms of parks, etc., fits in with the rest of the sustainability in terms of that design. So Esperanza asks about the relationship to policies that are going to regulate the building of affordable houses, making them out of sustainable materials, well insulating them. We have this thing in Canada where we insulate all our homes because you die if you don't do it. You don't have that same impact here. And having them not be 30 centimeters apart. So do you see there's a relationship between the evolution of both those policies?
I think there should be. I think in many ways they are in different departments in local government. So building regs go with the planners, parks go with the environment team, and unless they come together on a planning application, they don't often talk. I do often worry that we're trying to over-regulate specifications of both housing and development, to the point where people look at what do I legally have to do and just do that.
Yeah.
And that therefore takes away some of that innovation and some of the opportunity. But I think those conversations around particularly social housing, or housing that is not luxury, to not big 5-bedroom houses, and the way in which the environment supports personal mobility, supports like walkability and actually getting around without needing a car, because particularly in Manchester, a lot of people don't have a car. I think that's really important. And I think local government knows this and social housing providers know this. And it's just almost beating the drum a bit harder so that people remember this when they're having those conversations.
Great. So thank you once again, Ian, for a fascinating talk. And I think this really opened my eyes. It's not something I really had thought of before, but it's really, really cool. So we're going to turn it over to our second talk, which is being led by Professor Kevin Taylor. He does not like his job title, which supposedly has been forced on him by HR, but I'm going to use it anyway because I think it's funny. So he's Professor of Sedimentology and Tectonics, which sounds very impressive. And he's now going to talk to us about his research efforts within this Sustainable Futures platform. Kevin.
Okay, well, thanks, Mike. Before I start sharing, I'll just introduce myself so you can see me as not a disembodied voice. I'm going to share, hopefully, successfully my screen. Go. Okay, you should be able to see that now. Is that okay, Mike?
Yeah, if you go into, yep, perfect.
Okay. Okay, so good afternoon, everybody. So thanks for having me. Although on paper it may seem the two titles between Ian and myself actually might have much in common, one of the examples I'm going to use in my talk today actually is about aquifer heat storage, which actually has great potential for decarbonising urban heating. So I think there's actually quite an interesting link actually to which I didn't know would exist until I listened to Ian's talk. So that's a good one. So I'm going to give a talk about some specific, not the details. Those people who are hoping for a very detailed geology talk will be disappointed. Those who are hoping to avoid it will be happy. I'm going to give more overview really of some of the role that the subsurface can play in energy storage and some of the aspects of that and why it can do that and some of the challenges we need to understand and maybe get a bit more research on. And then I'll allude at the end to some of the specifics I'm doing with my colleagues mentioned here and other colleagues actually across the university, both in geosciences and in engineering. Some of the research we're currently doing is funded by both an EPSA big project and some NERC funding, and also we use Diamond synchrotron a fair amount for some of that high resolution work. So I should thank those people. So I suppose the first question really is up here is why do we need energy storage? Now, of course, I'm sure that the people in the room here could probably give a much better answers to the amount we need to store or don't need to store. But really, as we move forward to decarbonising our energy supplies, then clearly we have two issues which I think link into what I was going to talk about today. First of all, energy storage is needed because we have intermittent energy production from renewables. So this is the standard argument about wind and sun, never always blowing the wind, sun doesn't always shine. So we need to store energy. Obviously, we've stored energy for years. It's not a new thing, but there's an increasing suggestion that storing energy is becoming a more important aspect of what we need to do in the energy network. And also, we may be generating waste heat, for example, from commercial properties or from industrial processes, which we can also maybe harness and store for use later. So there's a couple of examples of why we need to use that. Obviously, if we want to store energy, there's a whole lecture course in how you can store energy. The obvious most people think of as batteries, and those batteries can take many forms, of course. It can be chemical batteries, which most people are familiar with as batteries. But a good example moving forward that people are discussing on the agenda at the moment and is one of the government priorities is hydrogen as an energy storage, which of course is a chemical battery. We can also store heat in the form, store energy in the form of heat, and we also store it physically in, so an example would be compressed air, or people may have heard of compressed air energy storage. Now, of course, some of these things can be stored at the surface, so, tanks and flywheels and lakes and pump storage and reservoirs, but actually we can also use the subsurface to help store some of this energy. And that's the focus really of this particular talk. So I guess the first question is why the subsurface then? Why can't we just store on the surface? Why is the subsurface going to help us? Well, I guess there's two real reasons why the subsurface could help us. First of all is that if we use the right geology, the right locations, there are potentially large volumes of storage possible. And secondly, if we do it right, and again, choose the right locations, then we can limit the surface footprint of that storage. So the benefits are there for us to be gained. Now, the diagram down here is really just to get you to think about the subsurface and maybe think about its use in the past in energy systems and maybe moving towards its use in the future. We can think of the energy, the subsurface, as being a continuum of either extraction at one end of the continuum, so we extract energy, and I think most people are familiar with that. We can extract oil and gas, and people are familiar with that over decades. Moving forward, there's also a demand for net zero to extract geothermal, which is extracting heat. So that's the extracting end, I suppose, of the subsurface. If we go right to the other end of the subsurface, we're looking at very much an injecting end of the subsurface, and that's using the subsurface to sort of for long-term disposal. The obvious two examples, which people are familiar with, is CO2 storage and burial in the subsurface, which again you will see is a government priority and is moving up the agenda as an item, and also nuclear geodisposal, either as individual deep burial sites or one large nuclear disposal facility. And that's very much about burying things in the ground in one way, so it's into the ground, and we don't want it to come back again, it's staying there. Energy storage has elements of both. We're looking at to inject it into the ground, to store it for a period of time, but then bring it back to the surface again to be used. So it's a sort of a midway point. And so it has elements of understanding both those sort of flow directions. Now, when we store energy, of course, so examples would be hydrogen storage or pumped air or heat. The length of time in which we're extracting and storing for will depend on the particular storage we're looking at. So it may be annually. So it may be that we pump down energy in the summer, in the winter, sorry, in the summer when the sun's shining, and then maybe in the winter it's being used at the surface when that energy supply is no longer there. So in a way, it's a two-way process. So we need to think just some of the challenges we have relate to this in and out mode, if you like, of extraction and then injection in multiple cycles, possibly even frequently, maybe even daily in some cases. So we can think about two examples, hydrogen storage and aquifer thermal energy storage, the two systems that we're currently working on. So they're the two examples really to use as good examples. And I guess some key considerations, and think about hydrogen. I suppose the first question which everybody will ask is, okay, well, what rocks are appropriate to store hydrogen and how? Okay, the obvious question. Well, it turns out that there's two major rock types which we can use to store hydrogen, and we have various levels of understanding about how that would work. Some of it we understand, we think quite well, and some of it would be a bit more work required. The first type of those would be what we call salt caverns. So there's parts of the world, and in the UK, the good examples are in the Cheshire Basin around Northwich, where they actually mine in salt. So you probably, if you live in that area, you know there's lots of salt mines under the surface, where simple halite, sodium chloride, is a deposit of rock that formed millions of years ago as oceans dried up, deposited salt, evaporated salt, and they now form thick units of salt. They currently, of course, are mined for rock salt or for other aspects of salt. And traditionally, they were mined simply by digging them out and classic mining and bringing material to the surface. But more increasingly now, they're mined by solutional mining, where you put fluids down, the fluids dissolve the salt, bring to the surface. But these salt caverns, which obviously is a good example here, can actually also be retro-engineered to store gas. And we currently do store gas. We store natural gas, methane, in these systems, so it's been shown to work very well. The reason why we can store gas in these caverns is that the rock, halite, is very, very impervious to gas and fluids, so it actually retains the pressure that's inside that. So we can create either by using existing rock salt caverns, or by actually creating new ones by engineering using solutional fluids to actually engineer caverns of the size and shape we want. We can actually produce caverns which can then be filled with, in this case, hydrogen. I won't go into great details, but effectively you can pump the hydrogen up to a certain pressure which the rocks which contain, and then you can basically extract the hydrogen gas for later use. The in-out aspect of these rocks is understanding not so much the geology, because the geology is fairly straightforward and simple. It's just a big hole in the ground with a very tight rock around the outside. The engineering challenges around the efficiencies of the system and how much gas remains in the bottom sump, i.e. never get back again, it's lost forever. How much cushion gas you need to actually push the pressure up and down. There needs to be a certain amount of cushion gas in there. And then there's a working gas area, which is the gas you take in and take out, take in and take out. Fairly simple, but there's but the limitations around this, of course, are that these rock types are quite locally, are only very locally available. So in the UK, for example, really the only location of these is the Cheshire Basin area. Some in Dorset, maybe at greater depths. So people are looking a bit more widely now to try and find other rocks that are more widely distributed that could be used to store hydrogen. And one of those rocks, which are called the porous rocks, that is generally viewed now as being potentially an excellent storage for hydrogen, is sandstones. And this is a thin section photograph, so it's basically a piece of rock with some sliced very, very thinly with light flowing through. And the difference between these rocks and the salt rocks is that these rocks contain grains of rock, grains together, which contain, in the blue here, are surrounded by a hole space. So these are basically what we call porosity, or hole space. And this is what can hold fluid. So in the subsurface, it will either hold water, or it will hold natural gas or oil. It can also hold other gases. It can also hold H2, it can also hold CO2, etc. So these rocks become, if you like, distributed holes in a large area, which can be used to hold hydrogen. But these rocks alone are not going to work without something to stop the hydrogen coming back to the surface again. Anybody who understands gravity knows that hydrogen is a light gas. It will tend to come to the surface. So what we need is rocks that have hole space like this, porosity, overlain by what we call seal rocks. So mudstones and shales, for example, which have no hole space and therefore do not flow gas through them. So they act as a cap or a seal to that system. And if we have a structure whereby there's maybe even a slight dome, for example, so if you imagine gravitationally, your gas will try and become buoyant, will try and get trapped inside that dome with an overlying mudstone cap, then that's your effective storage space for hydrogen. So potentially, it's a great opportunity, but there are also some more other challenges around this, of course, which you may imagine. So challenges around this are understanding the volume that can be stored, of course. So if we've got rocks that we recognise are appropriate, so let's say sandstones, how do we know how much volume there can be to store hydrogen? Well, that's a fairly simple question to ask if we understand the subsurface from drilling or from maybe geophysical surveys. We can start to understand we've got X volume of rock, it's got X percentage holes in it. So let's say typical values range between 10 and 20% of this rock is holes. So you can then estimate reasonably well how much potential space there is to store. So that's the first thing. So you can start to, that's a reasonably simple thing to do. And we know now there's some papers recently published across, particularly from Scottish researchers, which have shown that there's actually significant volumes of storage space in the subsurface in the UK that could fit that criteria. But there's other unknowns which we still need to really get a better handle on to actually de-risk or reduce uncertainties. And one of those is the ability of the cap rock itself to hold that hydrogen. We tend to have a view that the cap rock or seal, if it's acted as a cap rock and seal to other gases like methane, then it will actually act as a very good cap rock to hydrogen. But hydrogen, for those who know about hydrogen, is a much smaller molecule than methane or CO2, and it has a much higher diffusivity. It can actually get through much smaller pore networks. It can get through small microfractures. So some of the work that we're doing now is trying to understand the differences in how different types of these potential seals could act as host rocks for especially for longer term storage. If we're looking at annual storage cycles, we don't want to inject hydrogen into the ground and then find that a lot of it's getting up into overlying formations that can't be accessed. You're losing them. So that's one of the unknowns, and I think that still is under investigation. Another area which actually is a much more of a challenge potentially is this impact of continual injecting and extracting and injecting and extracting. If you're injecting and extracting, you're starting to perturb the system in a couple of ways. One way is you're obviously changing the pressure on a cyclical pressure, increasing pressure, decreasing pressure, And that can have impact upon your rock structure, and it may impact upon the porosity networks you have that may be very good to start with. If you start dislodging grains or start producing deformation in the areas of the borehole which you're extracting from, that may minimise or limit your efficiency of gas extraction and injection. Also, most rocks don't contain one grain size, so rather than simply just one selection of all grains, like imagine it, rocks don't look like a big pile of oranges piled up on the greengrocer's stand. With holes between them. They also have many different sizes of grains, and those smaller grains can block up the holes between the bigger grains. And we know from production from both aquifers, groundwater, but also from oil and gas, that we have something called fines migration, and that's if you've got fluids flowing in one direction or both directions intermittently, you can move around these fines, and these fines can form blockages within your pore networks, which again will lead to distinctive loss of efficiency in your system. And the last challenge, which is people starting to think about a bit more now, because it's actually fairly obvious when you think about it not for too long, is that there are also microbial impacts in the systems. Bacteria can live both in the surfaces, but also can be introduced into the subsurface from surface fluids being pumped in. And those bacteria, many bacteria actually use hydrogen as one of their food sources. They're basically, their metabolism, the energy from metabolism comes from the chemical transitions from hydrogen to H+. And so if you're pumping in hydrogen, and you've also got fluids in there that are fresh and maybe some nice other food source and there's organic matter gone in with it, you potentially produce hydrogen and perturb the microbial system, which does two things. One is it might produce biofilm growth, and biofilm growth will also start to clog up your borehole, your pores. If you've got biofilms forming, they'll start to clog up your pores, reduce efficiency, reduce volume of storage. And also, you start producing unwanted gases. So any sulfate in the system, which there are many, there's much sulfate in the subsurface. If you've got sulfate-reducing bacteria, they can produce hydrogen sulfide gas. Those of you who know about H2S, it doesn't only smell nasty, it's actually toxic, but it's also very corrosive. When it starts to dissolve, and it starts to corrode steel very easily. And therefore, again, you're going to start dissolving your pipe work and your borehole and your pumps and everything else. So there's something else that needs to be looked at. And so there's people in IB, Sophie Nixon in our department and MIB is looking at how to actually understand better about these subsurface impacts of bacteria. So quite a few unknowns there, which we need to understand better if we're to understand the longer term efficiencies of these systems. The other system, which is potentially a slightly different system, it involves heat rather than hydrogen, and it involves potentially much more widely dispersed opportunities across the UK. And that's something called aquifer thermal energy storage, or ATES for short. What is it? It's in concept, it's a very simple concept. The concept very simply is that in the summer, you have a building, usually these things have been developed for bigger buildings, usually like hospitals or town halls or maybe areas of development, small housing developments. And basically there's usually a cool borehole and a hot borehole, a warm borehole. And in the summer months, you basically extract heat from your building using heat exchangers, and you pump that down into your aquifer, into your groundwater, basically into your groundwater aquifer in your warm pump. And then you extract from your cool pump water that's pumped down in the winter, comes to the surface, can be used to, across a heat exchanger, can be used to cool your building. And heat exchangers between 5 and 10 degrees centigrade is enough to actually produce that efficient cooling. And then in the reverse, in the winter, you pump down cool water into your aquifer, into your cool injection, and then you bring your warm water back to the surface to heat your building in the winter. So it's a very simple system in concept. It's not extracting heat from the subsurface in the same way that geothermal is extracting heat. It's basically storing heat or storing cool, I guess, if you like, but both sides of the equation. And it's a very small difference in temperature, but it's enough to give you that, generate that heating and cooling in a sort of small building setting. So that's obviously, it requires two things. It requires suitable aquifers. So aquifer is basically a body of water near the surface, sorry, a body of rock near the surface that contains water. So across large parts of Manchester, especially Western Manchester, through to Liverpool, Warrington, is underlain by a rock called the Sherwood Sandstone, and that's a very good aquifer. It's got high porosity permeability and it holds water well, and it's widespread across the UK as well. And obviously you need a seasonal temperature change. Obviously, if you've got a cold winter and a warm summer, you've got a good contrast. If it's in the middle of the tropics where nothing's changing, then you haven't got any driver really to drive that. But in the UK, when we do have 10, 15 degree changes between winter and summer, it potentially is something that can be used. Now in the UK, there's probably about a dozen of these things that have been put in the last decade. In Holland, about 7,500 have been put in the last decade. So there's definitely potential, we see potential here to understand better how these could be utilised. Now, of course, again, there's some challenges with this. Challenges are it needs a good aquifer rock near the surface, so it does depend on the geology. So large chunks of Manchester would work, some chunks wouldn't work, depends on the geology. Some cities wouldn't work at all because they're set on mudstone plains. So it does depend a little bit on what the geology is. Obviously, if we want to understand thermal conductivity variations in the rock itself, so even though it may be 100 meters depth maximum you're looking at, so it's quite shallow, these systems, we do need to understand thermal conductivity variation of the rock. So is it high conductivity where we expect heat to dissipate and therefore will be lost much more quickly, or if it's low conductivity rock, the heat will stay more locally around the borehole. So there's that there. We need to understand vertical versus horizontal variability in characteristics. So, if you've got a tank, homogeneous piece of rock, then obviously the water and the heat will distribute in an isotropic manner around the injection borehole. If you have a very stratified reservoir, you may get some layers where it moves further apart, further away from the bore than others. So it's understanding that structure can actually understand the efficiency of the system. Is your aquifer flowing? So if you've got flowing water under the subsurface, and most groundwater does flow, it usually flows to, it's usually a pressure gradient in the subsurface that will usually flow in one direction. That speed will vary depending on various factors, the rock type, the porosity permeability, the nature of the actual gradient of positive pressure. But of course, if you've got flowing groundwater, that's going to have a different impact on storing heat than if it's static. So there's those things to consider as well. And then we're back down to the last two bullet points, which actually are exactly the same as hydrogen. We're injecting annually in, out, and we're therefore potentially changing the rock properties using this potential fines migration mechanism, which may be blocking up pores or other disruptions. And again, microbial impacts on the system. These are very close to the surface, so the temperatures are very low, and therefore microbial activity would be expected to be very high in the systems. So what are we doing to try and understand some of these things? Well, first of all, one of the projects we're working on a new, it's called the UK Geoenergy Observatory in Cheshire. So this is a site that's been developed, funded by the UK government and NERC, and also the British Geological Survey, to the tune of about £30 million for two sites. There's a site in Glasgow, which is looking at coal mine geothermal, which is something quite different. And there's a site that's being developed in the next 12 months, work starting on in Cheshire at Thornton, the old Thornton site, where they'll be drilling multiple boreholes into the aquifer to look at to do field tests and also to take samples out of the ground and look at the samples in more detail in the laboratory under confined experiments of maybe flows, different types of flow, different types of chemistry, different types of microbiology, etc. So this is starting, and they're drilling the first boreholes pretty much as we speak, and that's moving on. And there's a website that talks about the whole thing. All the data is public that they're producing. And then what we're doing on top of that, as well as doing field observations of the geology of these types of rocks, and we can the same thing really with hydrogen sites as well. Looking at the rocks and the hydrogen sites potential is taking all the stuff, all the fantastic toys that Manchester has to look at for imaging of these rocks at different scales, because we're interested in understanding statically what the rock looks like. So, what is the porosity, permeability networks? How can we predict? Can we understand? What the likely barriers to fluid flow in the surface are, or hydrogen ejectivity are at different scales, and then can we do experiments? Can we actually flow fluids through rock samples and look at damage to those fluid networks, or can we pump in fluids and fines and look at those fines moving in the system and where do they end up? And so we've been using a range of techniques that are in the Royce building, all the multi-scale X-ray CTs. We're using the diamond synchrotron, which gives us a higher energy source, allows us to do shorter term experiments. we've also been, what it lets us do really, of course, is multiple scales. So we can do things from, as geologists, we can look at the output, we can look at the basin scale using geophysics and seismics, but then we can take samples and put down at centimetre scale right down to nanometre scale. And some of the rocks we're looking at for holding H2 and holding fluid are at this end here, so we can use fairly what we would call low resolution techniques, look at pores in rocks that may be 10, 15, 20 microns in size, which is quite big for these things. But if we want to understand how hydrogen moves through cat rocks or mudstones, the seal, then we do in TEM work. It's down to like nanometer scale imaging. And so we have multiple techniques, stitch them together, a range of complicated challenges there regarding scaling up and scaling down, and that they're by no means solved, and obviously associated modelling. And so, we produce in 3D images, which you can start to understand. So this is actually an example to show a sandstone from outcrop, and we can start to measure the pore distributions, the pore networks, the pore sizes, and then produce pore network models, and we can produce flow models, which you can then also use not only to measure what's happening, but also you can then take mathematical models to try and forward model what might happen if you change parts of the system. Most nice images. And so, this is the sort of images you start to get. You can start to get 3D images of the rock, and you can start developing pores, pore networks, where the pore's connected, where the pore's not connected. It starts to produce not only static images of your data in 3 dimensions, which of course the real world is in 3D, but also helps you to predict how fluids would flow through that system. And in the case of reactive fluids like CO2, for example, which you're also working on, you can start thinking about how they might react in that 3D space and maybe dissolve things or precipitate minerals. And then finally, one of the real benefits of doing the work we can at, in both Royce and Diamond is we can actually look at things in what we call 4D. So we can take an example here on the left here, this is a rock plug or a piece of rock where we've actually flowed CO2 or flowed water through, and you can image the changes. That attenuation change means you can image that in real time. And so we can start to image both flow behaviors inside these rocks. We can image displacement of one fluid with another fluid. So this could be water displacing oil, or it can be H2 displacing methane, for example. And then also we can look at fines migration in real time using both tomography and radiography images. So I think I've run out of time. So really the take-home message really are that the subsurface is a sort of a currently largely is being explored by many people, both from the big scale to understand what volume is potential there for us to store. Of course, I'm sure many people will say, yeah, but do we need that much storage space? I mean, there's lots of questions about how much hydrogen will be used and how much will be stored. And of course, that's another set of questions which are sort of front load all this, I guess. Another point about the large scale is that if we go back very briefly to, I'll go back one, bear with me, there we go. All these things may be happening at the same time across an area. So you may be extracting oil and gas or something from one area, you may be trying to use energy storage in another area, and you may be trying to store CO2 in another area. And so these things, although you might have lots of storage space, if they're all trying to compete for this, if you're trying to compete with the same types of rock through these different processes, then there's a space issue, isn't there, and a shared space issue, and trying to understand which bits are best for that. But if you've only got one formation, you can do everything, but you can't. You can't store CO2 and store H2 and store nuclear in one location. You've got one or the other. So there's a challenge there about which ones are best and where. So it's not just about how much we've got, but it's where the best areas are. Okay, I think I'll just end it there because I'm very wary out of time. So I'll stop sharing. Okay.
Thank you so much, Kevin. I found that equally interesting. Again, if you have questions, then just type them in the chat and I'll read them out to Kevin. But I guess I'd like to start with one, which I think is really interesting. So obviously within the energy extraction community, there's been all of these issues around fracking. where there are geological consequences to messing with the subsurface. Is that, and I think of hydrogen, being a chemist, as something that blows up vigorously. So like, what are the safety considerations that have to go into projects like this? Because it feels pretty significant in terms of the other things that might happen.
Well, I mean, I guess, yeah, obviously, okay, it's a very interesting question. And the link to fracking is not necessarily spurious, because one of the things that, we've got colleagues in our department and many people around the world looking on what are called geomechanical properties of rocks. And we do know that if you change the pressure, first of all, changing the pressure in any system, so if you're pumping in pressure, releasing pressure, then you are potentially, that's how you will change the pressure field around the borehole, could potentially lead to the rock moving in various ways. It can either just physically move and expand, or it can actually have weaknesses or faults or fractures that then move and give rise to the surface vibrations, which people have recorded at some of the other activities. So there's certainly an area around pressure changes that is important, and that's, I guess, a physical process. Around chemical processes, and of course, yeah, there's always that concern. I mean, H2 isn't that reactive to rock. CO2 is more reactive to rock. H2 is not reactive to rock. If it's in the ground, I think the general feeling is, that's fine. But I guess the challenges around, and I'm not a chemist, the challenges around H2 and particularly H2 and its potential mixture of oxygen. I know it's got certain properties of oxygen that are not as desirable. Would be part of the engineering challenge of extracting and abusing the system. I think. But it clearly has to be looked at. I mean, the general risk, the general focus so far very much on both CO2 and H2, and also with radioactive waste, of course, is actually what moves away from the site you're using. So that's the first chemical question: what's moving away from the site you're using at what pace, at what speed? Ideally, it wouldn't move at all from any sites. I can't comment about the H2 challenge. I know it's the same question about people worrying about having H2 in their boiler systems at home. People go, well, H2 is very. But I know you can put H2 in gas networks, and it's deemed to be very safe. So I'm not a gas engineer either. So
yeah, it was more like, so you talked about how the rock might be aging over time, right? And is that a longer term issue? So someone forgets that someone put a bunch of H2 down there, and there's a few generations down the road, and then suddenly that's much more consequential than a CO2 storage cavern, which then goes and fractures and releases. That was more of it. But you're right. I think that the bigger risk is perhaps how that rock is interfacing with the rest of the system that enables the pumping, because that's where corrosion is going to be more significant, where you're going to be more likely to have leaks as long as that system is created. Which I guess is, would you say that the salt caverns, even though they're geographically isolated, would be less risky in that sense because they're much more permanent in a way?
I think, yeah, from what I've read recently, I think the general view is that salt caverns are a better bet in the fact there's less unknowns. Because they are, it is simple. I mean, obviously, even with salt caverns, there will be geological features which you need to be taken into account about losing pressure, about losing gas. That's one of the things that I know geologists are very interested in. But I think given it's a simpler system generally, I think people would think that. But I think that there's not an awful lot of them left. I think they're either been in the right place at the right time. Yeah, so yeah, there's a lot of risk assessment, I guess, we need to go into some of these things, which is why geologists and engineers should work together very closely.
Well, and I think it just highlights that it has to be an interdisciplinary conversation. So Esperanza has a couple of questions. So coal companies talk about carbon storage, capture, I guess, and then storage to offset emissions. And the concern is that if you store it inappropriately, it might release, which I guess is then I'm expressing a concern about release of hydrogen instead of CO2. So what's your take on this in terms of the studies that you're doing, and like, is there any you were looking at times in terms of the diffusion in, but that's not the time of very long-term storage. Is there an ability to look at how resilient those storage systems are going to be over the very long term?
Yeah, I mean, it's clearly, so yeah, for something that's long term, so obviously CO2 storage is a good example, and obviously the ultimate example of waste is yeah, any system is not just about the exploration phase of it, like, so what's in there, what space is there, would it hold, what are the rocks? It's also going to be about a long-term monitoring and modelling approach. So there's lots of, there's obviously monitoring associated with CO2, for example, which needs to be linked. You need to understand. We can use seismics or geophysics to actually look at some change in the subsurface as we inject the CO2. So the one example is the Sleipner field in Norway. It's been storing CO2 for 20 years. Equinor had what's called 4D seismic. So every X number of years, and a very detailed seismic survey shows pressure build-up, shows CO2 where it's occurring. Then obviously you need seafloor monitors as well. So the whole system will need to be monitored very, very carefully, very closely. But it means that the whole system needs to be assessed to be free of large fractures, to be not in an area where it's got regular earthquakes or volcanoes, and all these things need to be taken into account, absolutely. And they would be part of the design of the safety case for any site that's being used.
And Esperanza also raises a question I think is quite interesting, which is obviously there's going to already be potential biologics down there and biofilms. So is that just that discounts a site from being practical, or are there ways that you build that into the?
Well, that is an interesting question. I mean, with the deep sites, so I mean, hydrogen and CO2 storage sites generally are much deeper. They probably talk about hundreds, 1,000 feet. Well, sorry, old money, 500,000 meters. Unlikely to be biofilms down there. However, in the shallow aquifers, there may well be biofilms in their system because they're only near the surface. I might have to punt you over to Sedimentology on that one, because I think obviously the go-to way would be to put biocides down, but that's not necessarily the nicest way to do these things. Interesting question. David Johnson's put a link in there. Anyway, so yeah, I don't know the answer fully to that one. I mean, I think that has to be part of your assessment of the process, for sure. It wouldn't be a problem in the deep subsurface. Maybe more a problem in the modern, in the shallow subsurface, I guess, say urban aquifers, for example.
Yeah, I know it more of it being a problematic in petroleum drilling, which obviously is a different beast in and of itself. Maggie asked the question. Maggie, there are no naive questions in the world. So what's the justification for storing H2 in the first place, right?
I think it's a very good question, Maggie. I went to a couple of recent conferences workshops where there have been speakers who have tried to work out exactly what the demand for hydrogen would like to be and its rate of production. Yes, I mean, it will be from obviously green hydrogen, which is the ultimate goal. It would be for electrolysis of seawater or water from using renewables. But I guess, but again, if hydrogen economy was to become a big economy, which I guess is a question mark, then if you're producing hydrogen intermittently when the wind blows, for example, then the idea is that you might have storage sites on the subsurface as part of some energy island out there, which has got wind platforms and electrolysis, and then H2 stored in the subsurface for when it's needed. I think it depends very much on how much hydrogen becomes the economy. I mean, everybody believes hydrogen is important, but everybody has different views on how important hydrogen is going to be. So I think that's it's something I'd love to know the answer to, because we can all go away and look at these systems. If we don't need the systems to store them, we can ask ourselves why we're doing it.
Well, and it's so I again, as a chemist, I would naturally say, okay, I want to have an ammonia borane or something like that, so store it chemically. But of course, that's all down to the efficiency of the production system, and if you can couple that to the renewables, then does that make sense? And so it's a systems approach that's needed to be able to understand that. But I think what you're doing is really showcasing the need to really thoroughly look at the risks at that design stage, and it's very, very cool. So we are at time, so it just leaves me to thank Ian and Kevin for their fantastic and really interesting presentations. This just shows how in a single session we can have exceptionally diverse perspectives, Sustainable futures is a lot of different things. So please take a look at the platform, get involved. If any of you want to speak, get in touch, because we're setting up the seminar series for the back half of this year now. And thanks again for your attention.